Hey everyone, welcome back to the third and last session on mergesort. In this session, we are going to develop the code for mergesort and we do a brief analysis of the mergesort algorithm. So I hope you watched my previous session where I discussed a detailed example on mergesort as well as another example which was more of a code based and did some preparation on how the structure of mergesort code will look like. If you haven't, I strongly recommend that you go back and watch the previous sessions so that you have a much better understanding of what I'm going to discuss in this session. So I have a class app.java where I created an array. I initialized the mergesort class and passed the array and called the mergesort function, which takes the left side of the array, which is 0, and the right side, which is length minus 1, because the index starts from 0. Okay, here I have a couple of class members. One is the data, another is the length of the data. When the constructor is called, these are initialized, and after that I have the main function, which is the public function called from app.java. This needs to be private because this needs not to be exposed. Okay, so let's start with the main function. Here, if you remember, what I discussed is we need to take out mid, and mid is going to be left plus right upon 2. Okay, and as I discussed before, left needs to be always smaller than right. So if left is smaller than right, then only we are going to do our code, otherwise we won't do anything. Okay, after that we need to call the msort again for left to mid and mid plus 1 to right. So how we are going to do that? It's pretty straight. Left to mid, then mid plus 1 to right. Okay, and if we talk about the recurrence, where I have discussed mergesort recurrence a few times, the recurrence looks like this and this, which is a total of 2t n upon 2. Okay, then the third part is merging these subsequences, and for that we have a function which takes left side, mid, and the right side. Okay, so this is a very high level framework we are done with. Okay, and merges n sequences, so we can say its time complexity is this, or there might be some constants, so we can say it's Cn. Okay, so then total, or we can say our recurrence for merge sort looks like upon 2 plus okay, when n is greater than 1, and when n is equal to 1, that means we are not going to do any work and it is going to be the constant. So this is the recurrence for merge sort, and from this recurrence you can take out the time complexity of the merge sort algorithm. If you haven't watched my sessions on recurrences, you can have a look where I have discussed in detail how you can solve all these recurrences using different methods like substitution method, tree method, or the master method. Okay, let's move on. So our main function is done, where we are dividing the problem here, and then we are doing the merge step here, which we call here, and let's try to write some code. So now we are slowly merging our problems. So the first thing we need to do is, as we divide the sequences into two parts, we have two arrays, as I discussed in my previous lecture. So let's say our first part array is going to be mid minus left side plus 1, right? And second array length is going to be r minus middle. Okay, sounds okay? Now what I discussed is we are going to create two auxiliary storages because merge sort is not in place. There are versions of in place merge sort, but we are not going to cover those in this session. So let's create a left side array with size first and right side array with size second. Our arrays are ready. Now we are going to transfer the values from our original array to these two new arrays. Just note that I have discussed all this in my previous session, that why are we transferring? Because we want to make space in the original array for the sorted values. And for that, I need to transfer those values into a new place so that I can transfer them back after sorting. So let's transfer. For I am going to take because I'm going to use these I and j indexes later. So I don't have to initialize them here now. Okay. I is less than first, I plus plus. Fine. Transferring them to the left array from our original array, which is in the class, and which will go from left side of the array. Fine. And similarly, we are going to transfer the values for the right side of the array, which will go from jth index, which is 0, to the size of the second array. So this is going in the right side array, and that is taken care by the jth index, and our original data source will be done with, which is starting from mid plus 1 and plus j, right? Okay. Okay, so this is, if you notice, the right side of the array is from mid plus 1, and then we are adding the which index in that array. Okay, similarly, for the left side, it is starting from left side of the array, which is taken care by the left index. And what is the, okay, I'm sorry, it has to be I, L plus I. Okay, so for as we go on the ith index, so 0th index on this new array is in the original array from the left side plus the ith index. So the first index in the original array will be left side plus 0, left side plus 1, left side plus 2. So left side plus 2 is going to go into the second index on the newer left array, which is our newer storage. And we are going to keep the values here and then transfer back into this after sorting. I hope it's clear. Now let's do sorting. So I'm going to, and I'm going to take a new variable k, which is going to track the original index. I is going to track the newer left side of the array. J will be the newer right side of the array. And I will have a for loop, and k will go on from left side to right side. Okay, and let's see if any of the index I or j goes past the newer array indexes, we are going to break the loop. This can be checked in a while loop, but I just wanted to keep the code simpler for any of the beginner programmers. So I did not want to have this condition in a while loop, which makes it a little not easy to understand. So if I goes past the size of first array or j goes past the size of the second array, then we are going to break. Okay. Now let's transfer. So if left side of the value is smaller than right side of the value, we are going to transfer left side of the value in the original data, which is being tracked by K. And I will increment as well. And if otherwise, we are going to take right side, which is being tracked by J, and then we increment J as well. Okay. And yeah, I think should be okay. So we are going from K to where the end of this subarray is. We are going to transfer the values, and as soon as any of the indexes goes past the size of the first array or the second array, we are going to break. I think this is fine. Now what is going to happen? At this point here, we do not know which index went past. So we are going to check both. So if I is smaller than first, we are going to transfer all the values in the left array to the data, our original. Right? And if I did not go past, this while loop is not going to run. Similarly, if J went past, it will enter this loop, and we are going to transfer the right side of the array into the original data back from the newer array. That's why we created these two newer arrays, so that we can keep them here, sort them, and transfer back to the originals. So I think that's it. This should do everything. Let's see. Let's run it. Okay. And we did the sorting. Let's see. If you see in the debugger, our values are sorted. 0, 1, 2, 2, 3, 5, 8, 11. Looks like sorted. And that's it for the merge sort. So this was the code for merge sort, as well as the analysis we did. The analysis of this, and when you are going to solve this recurrence, this comes out to be log n. How this comes out to be log n? You will have to watch the recurrence session, which is already on my channel. So I'm going to end this session here. Thank you very much for watching, and I think it was informative for you. You were able to learn some code and how merge sort works. So I'm going to see you in my next session, which is going to be on quicksort. Until then, bye and thanks for watching.